welcome to the fourth time we're giving this workshop. This time it's finally being recorded. Very awesome. So in the next 90 minutes, we'll have a look at the NixOS integration test driver. And while earlier today we had a little talk with an overview what it can do, right now this will be all about demoing, like how to use it, how to hold it, how to get the best out of it. Also, I'm going to share some best practices with you. Because I've seen tests that, when you write extremely complex tests, they can become flaky, and you don't want that, right? So there's some experience that I want to share with you, how to make your tests as solid and fast as possible. Let's first have a little overview over the test and me. I'm the test driver maintainer, so I didn't invent it. So when I praise it as a amazing killer feature of NixOS, I'm not praising myself, because even before I started using NixOS, there was a test driver, but it was written in Perl back then. So I've seen the potential, but I didn't like the language. And in 2019, I proposed a Python reimplementation, which was accepted. And then with some amazing community action, within 2 months, we ported, I think, 600 or 700 tests from Perl to Python, because the core Nix packages team meant like, sorry, we can't like maintain 2 versions of the driver. Let's quickly switch over, and which we did. And since then, I experienced quite the skyrocketing adoption curve of this test driver, which was amazing. And nowadays we have like so many tests there, not only in the Nix packages repository, but also from all the customer organizations where we helped out. We've seen so many tests, and it seems to be quite the foundation of people who use Nix and NixOS to make their products reliable. So Nix packages already contains more than 1,000 integration tests. So whatever you need, sometimes you have like really strict or difficult requirements, and it is unlikely that no one else wrote a test like this before. So before you do anything crazy, please have a look into the Nix packages repository under NixOS/tests. And there you see all the 1,000 tests. There's stuff where they test like MySQL and PostgreSQL sharding over multiple hosts, Kubernetes tests, and desktop tests with and without graphics stuff, and everything. Everything you can imagine. Just open it up and look at your favorite services. They have some extensive tests about that, and from that you can inspire from very nicely. This is my favorite test example. So there's the BitTorrent test, and the colors don't turn out very well here. However, we have 4 hosts connected by this blue and red lines, which model a network, right? And to test BitTorrent, you actually have to create a torrent link and upload it somewhere, and then someone else downloads it and transfers the file. So what the test does is they create a new torrent file on the tracker host here and make it available from the website served by the Apache here. And then they fire up client number 1, who opens the link here on this Apache service and downloads the torrent file, opens it in the transmission client, which then downloads the file. And that test example, they just used the tarball of the hello package, but it could be anything, of course, right? And because we are orchestrating this from the host who runs all the VMs, we can test if the initial VM has the exactly same file like the receiving VM, which is very easy to test then. And after that happened, they actually switch off this transmission client here on the tracker and then switch client number 2 on. Now client number 2 has to get the torrent file from client number 1. What is interesting here now is that the red network models a home network. You see in the boxes below the IP subnet. And this red network is behind a NAT router with a firewall setting connected to the blue network, which kind of could be the internet, right? And for client number 2 to connect to client number 1, they need to poke a hole into the firewall, which happens with this mini UPnPD service that transmission has support for. And then the file transfer happens and the test stops and succeeds and tidies everything up. What is pretty cool about this is that you can immediately see how this is a halfway complex scenario, right? 4 hosts with all the networking setup and so on. So we're not only testing a BitTorrent implementation transmission here, We're also testing Apache, we're testing OpenTracker, we're testing the NixOS firewall, we're testing mini UPnPD and how transmission works with that, like a whole lot of software interaction. We're testing NixOS network configuration and NAT routing and whatnot. And all this is defined in 50 lines of code, 50 lines of declarative NixOS configuration, which is not a lot. 50 lines is halfway cheated. I kind of subtracted the boring lines that just contain brackets, opening and closing, right? But the actual configuration lines are roughly 50. And then that is just a declarative part, right? The part that says, please do this here and then do that there and then check this there. The stepping part, the imperative part is implemented in Python. It's really nice to read. And it's another 60 lines. So having something like this in less than 200 lines and executing within 2 minutes on a halfway new laptop is amazingly simple and fast. And that is the foundation of a really reliable testing framework. Yes, please? No, you would run all this on your laptop. I mean, it spins up 4 VMs in your sandbox, and they just run. You need 4 GB of RAM for this, roughly, so any laptop would do. The essential part here is, and that's a good question in that regard, you don't need any infrastructure, you just need one laptop with Nix installed, and then you can run 20 VMs inside that, however that makes sense in your test scenario, but it would just work. You don't need anything else installed than Nix, no infrastructure, nothing. There's also more interesting tests. My favorite graphical one is here in the upper left. That's a screenshot of the Chrome browser. All these screenshots that you can see here have been made in the test driver by the test driver itself. I just saved them after running the tests. And why do they test the Chrome browser in a graphical session? The reason for that is that the Chrome browser has like one specific feature that I test here, it's sandboxing. So Chrome was the first historical browser that put each tab into its own process to isolate them from each other. And then they throw a lot of sandboxing on top of it. And to test if Chrome is adequately sandboxed, you would open Chrome, go to chrome://sandbox, and there below this table it says, you are adequately sandboxed. And that's the string where you see if you are adequately sandboxed. There's no command line parameter where you could run it on the shell to ask Chrome about these things. So you have to run it graphically, and the test does that. So it defines a graphical VM, boots up to the desktop, starts Chrome, clicks into the middle of this window and runs copy and then pastes it to a buffer, where we can then check if it contains the string you are adequately sandboxed. That's what the test does. And also runs in, I don't know, something like 2 minutes. There's a bit of overhead to get to the desktop, but that's basically it. And they even parameterized that test to run with all the different Chrome binaries, so it's really, really elegant. The other tests are GNOME, the desktop environment, and then also some computer games where they test the client-server functionality. So if one client sees that the other logs in, that implies 3 VMs in both cases, 1 server and 2 clients. And it's not a lot of work to spin up these kinds of tests. Sometimes I have QR codes on the slides. That's blog posts on our nixacademy.com blog, because we had some content here that covers this. What's also interesting, there's a test with VirtualBox. VirtualBox is itself a virtualization solution. And the test driver runs VMs with QEMU. And then they're running VirtualBox in QEMU. Of course, that would be pretty slow, but what they're actually testing there is if VirtualBox in its package configuration, and it's really a complex package, works with certain VM configurations. There you don't need to see that it's quick, you need to see that it's not crashing with errors or anything. And they are testing a lot of scenarios here to see if that works. So there's a lot of software that is tested with this thing, and I don't see many reasons why your software wouldn't work in that. You can also run integration tests on macOS, because, of course, macOS can natively run QEMU, and then QEMU can run those VMs, and that's it. It's just that macOS cannot natively build Linux VMs. For that, you would have to set up the Linux builder, and we also have content covering that on the nixacademy.com blog. So if you're interested in running this on macOS, visit our blog and read the article. and after 10 minutes, you're set up. How does a test now generally look like? In general, we would write an attribute set like this, like on the right half of this screen. And each test needs a name that becomes part of your output path. And then we have this blue part. This is the most important one. This is the declarative part of which I claimed that the bit turn test earlier would be just 50 lines. So here you pile up all the VMs that you want to have. Here we call them machine 1 and machine 2. And then the green part is the imperative actual test that does step 1 is this, and then do that, and then check this condition, then check that condition. And if anything here fails, the whole test fails. And I exaggerated it a little bit with like writing a for loop for these 2 lines of code here. This is just to demonstrate that we have real Python here. So you can actually import third-party libraries and do whatever you like, whatever you would do in Python. And what's cool here is because we configured those machines to be machine 1 and machine 2, we get Python variables that are also machine 1 and machine 2. So that's generated for you. And you see that these machines ping each other here. And the network names are also machine 1 and machine 2. So this synthesizes machine Python variables and network DNS hosts. Of course, network means there's a lot of configuration being done for you. That's the default configuration. You can override it all. But in most tests, people are not interested in figuring out a huge network configuration, and they just use the defaults here, which are very useful. There's also this orange part. I can show that to you later in detail, that this is another NixOS configuration line. The defaults mean that it's injected in every VM. So you can kind of pile up standard settings here too. I just abbreviated this here with those 3 dots. That's our real-life NixOS configurations. So what's cool is that you can typically have very real-life-like NixOS configurations in your tests here. That's nearly what you are deploying on your customer systems to be like very near towards the scenarios that you actually want to always work. This whole attribute set is not by itself yet a derivation. So you'd put that into your test.nix file, but then you still need to feed it into another function. That is packages.testers.run NixOS test. And that wires together the whole test driver thing for you with all the VMs and everything. And then also builds it inside the sandbox for you in one step, as we will see very soon in the live demo. However, at runtime, you basically get this. We are looking at everything from the perspective of the driver object, which is like the orchestrator. And that has access to all the machine instances, machine 1, machine 2, however you named them. And it also wires up the network, which you can also manipulate. What's cool here is that you can not only run commands on the VMs, you can also switch them on, switch them off. You can make them offline to appear like network outage that you want to test, whatever you like. Screenshots and everything, right? So this is basically like a building block framework to do anything you could do with a physical lab in front of you. All the commands that come with the framework, like start the machine, stop the machine, succeed or fail with a certain command, connect it from network, and so on. This is all documented in the NixOS documentation. I will show it to you later when we actually look at the running test. If you want to check this out, what we're doing right now, that's in that repository, github.com/applicative-systems/NixOS test driver nixcon. The QR code also leads you to that. So everything that we do today is in that repository. So you don't miss out if you try this at home. So the first test that we're going to look at is the ping test. I have a attribute set like on the slide before where wait, is it large enough? The name is called ping test, and ping test will be kind of the output folder. It's relatively boring. And then we add 2 machines. So we say nodes equals, machine 1 and machine 2. An empty configuration already provides enough defaults for a machine to just normally boot up and log in with user root without a password. That's enough. And of course, the command ping will be installed in those defaults. So that's kind of the most boring way to set up a scenario with just 2 machines. And then when we scroll down, let's ignore the global timeout and defaults for this moment. There's the test script. Let me remove the comments here. Where we say start all. This is one of the documented commands that just runs all the VMs, so they start up in parallel. What you could also do is you could say, let's start one VM and see if it comes up at all. Because you test it in some complex way. And then only if that happened, then you want to run the resources to also boot a second VM. So you can actually do a lot of decisions here and design to make your test fail as quickly as possible while saving resources on the way, or just do everything in parallel. Depending on your test, one or the other thing makes more sense. Then here we're waiting for the network online target. That is relatively new. A little bit more than 1 year ago, no test ever contained that because the network online target was a default. They removed that because other Linux distributions didn't have that either. And now you have to explicitly start the network online target on both machines, then wait for that to happen. And then we can ping the machines. What's interesting here, we could also say machine 1, systemctl start network online target, and then machine 1 wait for that target. But then this start command wouldn't happen on the second machine in parallel, right? So that's already your policy decision how you want to parallelize or not. And at line 24 and 25, we know that the network is now active and the ping command wouldn't fail if you were running it prematurely, right? So this is the first step towards like non-flaky tests. Do like assert as much as possible about the functioning of your environment. And now the last two lines in 27, 28 finally do what we actually wanted to test. Machine 2 pings machine 1 and machine 1 pings machine 2. What's also interesting here is that succeed is a method that runs execute, and machine 1.execute would return your 2 tuple. That's the standard output and the success code. Here we just want the test to fail if we don't get success, and succeed does that. It would throw an exception if we wouldn't succeed. Now what's also interesting here, I'm running ping-c1. What do you think? Why would I do that? Why wouldn't I just run ping machine? Exactly. So ping would ping indefinitely, and there's no real way to stop that. You would actually have to find out the PID and then kill it from somehow, but we are blocking on these things, so there's no feasible way to do that. You want to call all your commands always in a way that they are quitting at some point, which does C1 with ping, right? And that's basically it. Let's have a look and run it. Let me rename the test, otherwise it would come cached. When I run nix build.#ping, so in the flake file in this repository, that's the attribute that points to the test here. Oh, before we run it, let's have a look at it. Because of course, we do run packages.test as run NixOS test on the default Nix in the ping folder, right? So that transforms the attribute set into the actual derivation. Why we only pinged once, or why we could have done it twice too. Yeah. But if it doesn't work once, then it's broken. And if it works 3 times, then at least in that environment, I wouldn't care too much. Okay, let's run the test now. Nix build.#ping. I'll add -L. Otherwise, we wouldn't get a lot of output. And you can now see that it takes a few seconds to evaluate and build the test driver. The test driver also does like linting of the Python code and formatting and stuff like that, and would fail if it finds some superficial problems there. And now you can see that we are through already. So we are flooded with boot messages, blah, 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 all this stuff here. You can see the colors already. The gray means this is just background system messages spamming. You would only read them if there's a problem. So let's get to the beginning. Oops. Okay, it's quite a lot. Let's jump to the end again and look at the important things. Here in green, you see, I hope that's still readable. Waiting for unit network online target, that's machine 1, right? Then machine 2 waits for unit network online target. And if you get any problems in between, you might most probably see them in the system messages, right? So this is the first insight if something doesn't work. If everything works, then we actually don't care, right? And then we have the actual ping part. So the test driver prints in green what it does. Then there's some diagnostics here, how long this took. And you could actually print the output. But what's most interesting, that the whole test just took 6 seconds. So in 6 seconds, we have been booting 2 machines, ping each other, and then destroy and collapse everything again. So there's no trace of the QEMU processes or whatever running any longer. Okay, let's change the test a bit. So because this is Python, we can say output equals this, and then print output was print output. And this way we'll just get more output, right? But it won't be surprising what it will be printing. We see again that it takes a few seconds to evaluate the thing and lint it and so on. You can always disable the linting to get another extra second of faster feedback. Here we can see output was all this stuff, right? So yeah, this is the ping output. Now you can imagine that it's actually trivial to, on the Python level, to assert that you have some substring inside here, or if you have like applications which, I don't know, print out JSON on standard out to deserialize that and access a few fields to check if everything is all right, or if some error is, I don't know what. You can do whatever you like, because if you are proficient in Python, you can already imagine yourself how is it easy to get out the right data. We have seen that building the test equals running it. Let's have a look at this runner script that we have here. Oh, no. The thing is, the result is basically an empty folder. So it points to the ping test2 output folder. And the question is now, why does the test driver create an empty folder? The thing is, the Nix sandbox works in a way that you describe all your dependencies and which command to run in the sandbox. Then we wait until that command finishes. And typically, that command would be some kind of build system that compiles an application and then copies all the binaries into the output folder. And then the real package has a bin subfolder with the binaries and the lib subfolder with libraries, blah, blah, blah. What does a test produce? When the test was successful, what would we care? I don't need any output from a successful test, right? So the thing is, however, Nix would declare that the whole derivation had a fail if the process doesn't exit with the success code 0 and produce the output folder. That's the minimal interface between the processes in the sandbox and the Nix daemon. So we create at least an empty folder, and that means that the test was successful, right? If you create screenshots or stuff like that, they would be available in here.
Or if you ran like an XUnit type test inside.
Yeah, you can create all kinds of output there and throw them out and reuse them later. That's up to you. But for a normal test that doesn't do a lot, we just don't care. We just want that it succeeds, and then no one looks at the results of a successful test, right? So how do I look at the actual scripts that are running there? Because I just get the output of the finished thing here. Instead of just running nix build the ping test, we could say .driver. So the sub-attribute of this derivation contains the driver that it actually runs. That's available in all the test derivations that you build with packages.testers.run NixOS driver. Here we can now look into the folder, and then we get a bin output with NixOS test driver. And when we look there, at the last line, we're actually running something, and everything before that is just setup. So we see start scripts, and here you can see something with machine 1 VM in its name, and here's something with machine 2 VM in its name. So that seem to be the run scripts. Everyone who has ever used the NixOS profile QEMU VM from the virtualization profiles folder will recognize that, because even without the test driver, you can just run a build and run VMs. And that's what we're reusing here, basically. And then let's have a look. what did I do here? Okay. So that is a bash script that would run machine number 1. And the bash script for machine number 2 looks similar, of course. What's interesting here is what I wanted to show you. There's a lot of garbage happening here, setup that's not interesting right now. We see that it comes with its own version of QEMU, which is fine. And then it sets up the VM with 1 GB of RAM and 1 core. This is all defaults that you can change in the test driver via the QEMU configuration options. And the thing that I want to get at now is that we are mounting the host's Nix store into the VM. You might have imagined when we built a test with like, I don't know, 15 VMs, we would build like 15 images. And that might be, I don't know, 30 GB of space even before we run anything. And then you change something, you would build images again and again and again. That's how test frameworks worked before the NixOS test driver, and that's why no one would use that. This driver works without any images. So we are basically just building the top level closures, the so-called ones for each VM. So we pile up more and more folders in our Nix store of the host. And then we start kind of a shallow VM that doesn't really have a disk image, but it has access to the whole host Nix store in a read-only fashion. And then it just needs to pick the right path that describes the VM's configuration, which happens a little bit lower here. So with access to the host Nix store, we pick the initial RAM disk for that VM here and take the kernel parameters and the init script. And this is all stuff for this specific VM. So we're just rebuilding a few paths and then can rerun this stuff. So that's kind of why you get such really, really quick iteration cycles. You can describe 10 VMs, run the test, and you're not happy with it. So you forgot something, and you change the config and run it again, and you're running again within seconds. That's why we don't use any images. That's why it's so fast here. That's also why we're not clogging your laptop or the build infrastructure with unnecessary images, right? Okay. The other thing is, you have seen that this test runs in a few seconds. One reason for that is that it uses KVM. To check if your system really is KVM ready, you run ls on dev KVM. If it exists, that's a good first step. If you don't have KVM, then the test driver will still run. It won't produce any errors. It will be just horribly slow. So if your test takes more than 20 seconds for something like this, then you are most likely not running with KVM support. It's also important that you are that you have write access to that file. So I'm in the group KVM, and also the Nix daemon is too, because when you run in the sandbox, it's not you who are calling QEMU, it's the Nix builder user. So you need to set up your sandbox and everything accordingly. On NixOS, that's the default, but I've seen people that had like problems with this on Ubuntu, Fedora, whatever. I've been using NixOS for 10 years now, so I don't know how to properly set up Ubuntu or Fedora, but that's something to look at and to fix if your tests are slow, right? So rule of thumb, booting 2 VMs in more than 20 seconds, that is slow. And then you have to fix something, and it's most probably this. Okay. Another thing for unclogging your build infrastructure, because right now I'm thinking of, let's say you have like hundreds of such tests, each of them takes just a few seconds, so that piles up nicely. But then you have hundreds of developers too. And then you have a build infrastructure which gets clogged with hundreds and thousands of tests running all the time, beginning in the morning, ending in the evening. And then when there's a test that fails, let's say you're stuck on the network configuration and something just hangs. If it would hang for the whole day, then you're clogging a build slot there, right? What you want is that things fail very quickly, but sometimes they just don't. And for that, we have this global timeout top-level attribute. This is also nicely documented in the docs. You want to set this to some tight value. The default is 1 hour, because this flag has been introduced just in the last years, and most tests run within 1 hour, so that's it. But if you know your test should run within 5 seconds, give it a 10 or something, and then you know that if your test fails in a silent and blocking way, you are unblocking the build infrastructure for your colleagues very quickly. So that's something to consider. That's one step towards a really tight and fast code base. Then there's another test. Let's go towards a real life scenario. The Echo server. This is a Python application that I built as a toy example. Here we are basically accepting a port number on the command line, right? So this has nothing to do with the test driver yet. It's just a client-server Python example. And then when we have this port number, we open up a socket and listen to it. And then whenever someone connects, we accept that connection. And then we read from the input, and then we simply echo it out again. So if I run this application with Python and then connect to it with some kind of client, I say hello, it will send back hello. What I want to do now is I want to run this as a real service on a NixOS system. Let's imagine this is an awesome product and we now productize it. And I want to automatically test if that works, including firewall settings and whatnot. So let's stop this again. To actually make this configurable in a NixOS system, we need to provide a module. And the NixOS module typically looks like this. So this is just a small deviation into NixOS modules, where we say we want to have an option that's called services.hello.enable that someone can set to true. And that not only installs the Echo package, so to say, but also runs it as a systemd unit. That's what you typically do under NixOS to provide others a nice interface to run your software in a configured system. And there's also services.echo.port, which we can set up. So if someone wants to serve on some other port, they can just do that. And then we have this shorthander here that accesses the future config as the user set it up. And then we have this object CFG that contains the enable and port attribute. Then we can see how would we react if someone actually enables that. That's what the config part does. So in our trainings, we have a day to study all this stuff. Right now, we just do it in 30 seconds. So if hello is enabled, then we're adding this snippet to the configuration, this whole snippet. And that means that we are adding a systemd service called Echo. And it's the friendly TCP Echo as a service daemon. And is wanted by the multi-user target. So it's launched by default, kind of, right? It's actually, it should also need network target or whatever. However, I didn't invest a lot of work here. What we're doing here is we're running Python 3 on the Echo server script. And we take config.port, that services.hello.port, transform it to a string and append it to the command line. So we are basically just running Python as I did before on the command line, but it's nicely configured now. Of course, this is kind of a toy example, and real life services are a bit more, have a bit more finesse, but this is just a simple way to run this. Now let's look at the test. The Echo service test has nodes server and client. You can see that the client is empty. It will just need a netcat instance to test the service, and the server config is more interesting. On line 9, we are importing this module, and that adds those services.hello.blah blah blah lines. We can now use them. And on line 12, we enable the Echo service. And what's interesting is we are keeping the default port, which is, I don't know, I think 8,000 or whatever, I just forgot. But regardless of what it is set to, we want to open the firewall here. And what's interesting is in line 6, we can again access the future config, as it will turn out. And in line 15, we access config.services.echo.port. So regardless what someone else has set it to, we can say that we allow this specific port, which makes everything pretty much dynamic. And that's already the config. So service is running, firewall is open, client should be able to access it, right? And that's what we want to test. Let's look at the actual test there. This is a bit more complicated than before, because in the example with the ping test before, you've seen test script was simply a string. What we have here is test script is a function that accepts an attribute set in Nix syntax that has at least the nodes attribute inside there. And then it returns a string. Why is that useful? The thing is, if someone set the port to something else, then the test would break if it hard codes the port number, which we don't need to. Here we are accessing the nodes as we have defined them further above. And then in line 32, we are declaring a Python variable called echo port. And that accesses nodes.server.services.echo.port, right? And now the Python script automatically adapts regardless of the port, just as the firewall does, which is really cool because if you have really complex tests with complex settings, you will never ever have to hard code something or change stuff at multiple occasions. And then we're waiting for running start all, right? And then we're waiting for the unit echo service. Then in addition to that, in line 38, we are waiting for the port to open. I will explain why that is so important to do this double check kind of. And then on line 40, we're starting network online target of the client and wait for that. And in line 42, the actual test happens. So we are running client.succeed. And we're echoing kind of the text stuff from the variable up there through netcut to the server. Again, we can see that we can call the server because the variable in the test driver in the nodes was called server. So we not only get a Python variable server, but also DNS name, right? And then we are actually saving the answer in the variable output. And here we can say assert echo text in output, which is just pure Python, right? And that is the test. Now, you can imagine this would run again in just a few seconds. We can try it out soon, but I first want to discuss why do we do this double check after we made sure that echo service is actually running, that it also opened the port. Because the test would totally work without line 38. Just ignoring this port test, there would be enough time between checking the service starting and then bombarding it with input and testing if it answers. But sometimes it happens that on a slow laptop, this runs just fine. Then you call it a day, commit, push stuff, drive home, and then you see on your cell phone, oh no, the CI went red. And then it times out or something. What the hell happened? That is a source of flakiness in tests, where something that you don't control is your laptop is slow and the CI is very fast and might have like 10 more cores than your system. So on such a simple test, such a race condition is improbable, but with more complex tests, this happens. And what we're doing here is we are waiting for the echo service to start, but just because systemd sees the process running, it doesn't mean that the port is really open. There's the systemd feature of getting notified that the service finished its startup, but not all software does this, so this stays relevant. And after we've seen that the echo service is running, we test if the port is really open, and after we've seen that on a slow and a fast machine, everything is set up to test. Now we could ask, like, why do we actually wait for echo service if we can just wait for the port? Because if the port is open, that means that the service is running, because otherwise it wouldn't, right? That is important to do still the double check, because if the port does not open, the test would hang. Of course you can configure timeouts, but it's a stupid reason to hang. If the port doesn't open because your application parses some configuration line and fails very early, then the first line would give you that and would even give you a readable error message. You wouldn't get that. You would wait for unnecessarily long and not get a good error message. So that is why you do this double check, because it makes the test unflaky, and whatever reason we have for the whole test to fail, we will see it on the terminal and we will see it quick. So that's another experience to consider. We have now seen considerably many different methods here. So where do I actually look this up? Wait for unit, wait for port, wait for this, wait for that. There's a lot of very specific things. And where do I know this from? You would typically go to the NixOS manual. So that's nixos.org/nixos/manual. I mentioned that earlier in the talk. You will never ever find this on Google, because this is one huge site, a HTML page, and Google doesn't index pages of that size. So you will never find this on Google. But if you work with NixOS a lot anyway, you would just bookmark this and run Ctrl+F. Here we can scroll down. There's a lot of NixOS manual stuff, and at the very end, there's development NixOS tests. whole chapter about it. I recommend reading this once. There's a lot of stuff that I'm not mentioning in this workshop and examples and stuff like that, blah, 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 testing this, testing that. This is how you set the memory size of the nodes and everything. Machine objects here. All the Python methods that we provide for those machine objects are nicely documented in the Python code, and we automatically generate this HTML page from that. So it's complete and up to date. And this is something where you would read over once to see what's there. There's this block method, which simulates unplugging the Ethernet cable. There's a console interact thing. There's like a cheap SSH session. You can copy files from the host to the host and blah, blah, blah. You can crash the machine. You can dump TTY contents and whatnot. So this is something that you should at least read over once, and then you will get an idea what you can do. Yes, please?
So on your Nix file, you had the .machine in. Could you also just import the dig and use the dig services then?
One moment. Let me rephrase your question to see if I got it right. So instead of writing client or server,
No, about line 34.
yeah,
So you have node.server, .server, that's that. Would you replace the nodes.server and just import the dig there?
no, not really. The thing is that this nodes attribute is the result of the evaluation of your configuration. And if you just import a module, it might not be exactly the same thing, and that would be kind of fragile then. And you get guaranteed exactly the configs that you just described above.
Okay.
Some configs are really complex, right? You kind of compose them of multiple files, and this is guaranteed the same. Okay. Okay, let's quickly run the test. I'm just invalidating the cache by renaming the test, or you could also add a new line in the Python code, whatever. And we could run it again like this. Oh, actually, I typically don't use nix build-l. I use nom, the Nix output monitor. It's another package. It's called packages.nix-output-monitor. And it's pretty cool because it shows you the dependencies that are built. If something takes longer, you will see why. And then it also gives you the output here.
They'll give you an expected derivation data time.
Okay, we see that the test took like 6.46 seconds. So that's the net time without building the test itself. It's just running the test, right? And here we can scroll through and see that hello world actually resulted in what we wanted. And we have the same white, green, and gray messages again. So this is all nice and cool. And actually it's port 8081. I already forgot about it, but I also don't need to know, right? So this is pretty cool and a nice way to write those tests. Something that I want to show you is how would we extend this test to patch everything? Sometimes you don't know what you actually want to test because the software is so complex and you want to find out which programs do I even run to generate the output that I want and stuff like that. So you want to get to know the interactive mode, because right now we just build the test and run it in the sandbox, and we're like outside watching the inside of an aquarium kind of, and you couldn't interact with it. That's especially annoying when you have a test that runs for an hour and then fails, and if you change something, you have to run it again for an hour and then change something. 3 hours later, it's still not done, and you wasted half the day. The better way to do this is you build the, not driver, but driver interactive sub-attribute, and then it doesn't run the test, it just builds it. Now we can say and run it. And we're now in the Python shell. So you can actually say server dot, and then kind of look through all the methods here. And then you can see what you like. And then we could say server start, for example. And what's cool is what doesn't happen in the sandbox. You get the QEMU window popping up in front of your face, so you can actually log into that VM now. You can say root, and with the default test driver settings, you have a passwordless login here. Unfortunately, the window is very small right now, so you would have to live with that, but I will show you the SSH capabilities later. You can run systemctl status. And there, somewhere between lines, we see echo service, and then you see that we have a real-life systemd unit running there. And if it failed during startup, you could now diagnose what's wrong, right? So this is pretty cool because this is a real shell. It's completely the wrong resolution for this scenario here right now. But now we can also say client.start, and it starts the client. Of course, while this all happens, the terminal here is spammed pretty much, so you would wait until it calms down. What's also cool is we can say client.screenshot. Oh, file name is lol. Now it created lol.png in this folder. So if I press Ctrl D now or exit, it asks me if it shall throw everything away again. Now we see the lol.png file, which we can open, and that is kind of the terminal. Of course, it's boring, but it's a screenshot of the running system. You could kind of, if you have some kind of website test, you could create screenshots and then share that later or whatever, right? Now back to the situation that I want to play with that VM. So I was able to play with it. You guys were not able to read it because the output was so small. Also didn't have any copy and paste and stuff like that. So maybe I want a real SSH connection to the driver. That is interesting because there's something new, relatively new. We can go to default Nix and say we could import settings here or enable SSH and do port forwarding and stuff like that. And if you want to SSH into multiple machines, you would have to allocate different ports for that. So that was something that we did in the past. And that looks like, like this. So in the past, you would have, and I'm going to show you a simpler method, enable SSH on that system so that you can log in at all. And then you permit root login and permit empty passwords, and you allow PAM to allow that too, because there's all kinds of security settings that we would need to disable. And then finally, you would forward the host's port 2222 or whatever you like to the guest's port 22 to finally log in. And that's super inefficient and nasty to set up. And I typically, when I don't have this as a template, I'm Googling for half an hour, like what were the plethora of settings that I have to switch off to finally get into that VM. Forget about all of this. To actually get the login here, what you do is you go into your test file again. And here you can say SSH backdoor.enable equals true. That is also described in the documentation. And when we now run this test driver again, or build it first, takes another second because it's essentially reconfiguring the VMs. Now, you can run the test driver again. What you can now see here is to connect to the client and the server, it gives us these lines here. And you can see here it uses vSock. vSock is a specific kind of socket that's not a network socket. It works like a network socket, but it's a virtual machine, I don't know what socket. So Linux, the Linux people invented this so that you can have like efficient communication between the host and VMs or multiple VMs between each other, even without setting up network. So if you disabled network in your test, you can still SSH into that machine. And vSockets don't have addresses, they have numbers. So client will work on number 3, server will work on number 4. Let's copy that line. And then we can say run tests. So that's kind of just running the whole script. I don't care right now. And then the VMs pop up in front of us. Now I can copy that line. Hopefully SSH is already online. Now I'm in the client. And here you can immediately see it's easier to read because we can actually zoom in. But let's go to the server. Say systemctl status. And now we can finally see there's the echo service and everyone can read it because we're in a SSH session. So this is pretty cool. You can copy and paste here. You can, it's nicer to work with kind of, right? You just open multiple terminals and that's it. And that's a very nice interface. So the significance of this is that this helps you playing around with VMs and find out how do you even test your stuff, because you might have to tinker with this first. And then after you found commands that sufficiently and satisfyingly test your stuff, you would set that install in your test script, and at the end of the day, you just run in a sandbox and find out it's fine now. The other use case for that is if you have a breaking test in the CI. What people typically do when they see a red CI is, what's the first instinct? Failing CI, which button do you press? Reset, rerun, or whatever, right? Hopefully it just works and it was just a hiccup. In Nix, we know that that doesn't really happen, but what you don't want to do now is to look at the code, at the CI output, see what error you see, and then do guesswork, like, okay, let's change the code somewhere, commit it, push it, and then wait. And then 2 hours later, it's still broken. That's not the workflow that we want. What you do in Nix is now basically you find out which attribute actually failed in your CI, and then you run the same thing locally on your laptop. And then you see the same kind of fail most of the time, unless it's one of these flaky tests, right? And then you just build the interactive mode and let it run, and then let it fail, and then the test just stops right there, and then you log into those VMs, and then you play around with log output and stuff like that. If you find out that the log output is not sufficient, maybe you can just stop the test, install more debugging tools, and then run it again, and then debug everything with Wireshark or whatever you need to debug everything. And then the first commit that you set and push already contains the fix without your debugging changes, and then you're fine. As soon as it ran sufficiently on your laptop, you can commit, push, and drive home, and at home you won't see a red message again. So that's the typical workflow. It's a huge improvement towards what people were used without Nix, right? Okay, then there's also this feature. Oops. What I want to mention at least, that, where was it? There's a debug hook. So, you can also, instead of saying SSH enable, backdoor enable equals true, you can, in addition to that, add enable debug hook. That is a very specific feature. I'm mentioning it not because you would use it all the time, but if you need it, it's a lifesaver. So the scenario is the following. The test fails in the CI, but it doesn't fail on your laptop. Actually, it fails only in the CI every 3 months or something. It's a Heisenbug that's hard to track of. And then if it finally fails on the CI and the CI throws everything away, that's not helpful, because you know you won't trigger it on your laptop. So what to do about cases like that? On a hackathon, someone told me that they are running Ceph tests, which run for 3 hours, and they fail sometimes, but really rarely. The latest feature here enables a debug hook. Debug hook means the test runs until it fails, and then it stops. So the QEMU process kind of produces some error or whatever. The test driver kind of would stop there. But with this parameter, test driver would wait indefinitely and print those commands at the bottom that you can now use on the same builder machine to log into the sandbox, and then from there log into the VMs. And then you can read log files and whatnot, and hopefully it contains all the information that you need. So that is a once-in-a-lifetime lifesaver, kind of. It's nice to have it there, although I never use it because my tests are pretty much solid. And however, I know what I would do now if there was a test that just fails every 3 months, right? So it's totally noteworthy, and it's also documented in the documentation. Yes, please. Mm-hmm. Mm-hmm. Yeah, for example, I mean, of course, it's a question that's not related to this feature here right now, right? Okay, so if you want to have a writable Nix store in the VM, that's not the default, but it's possible, especially when you want to test Nix in the NixOS test driver, then the Nix demo needs to write into a Nix store. There's another flag that gives you a read-writable store. So they put an overlay file system over the host store, and then the guest has its own copy on, own writable part on it. And then you can pile up more stuff, and then it gets thrown away after the test collapsed again. It's just one additional flag, virtualization dot, I don't know, read-writable store path or something. It's an overlay FS that is being thrown over the file system. If you want to, I mean, we would have to dig into the QEMU vm.nix profile now because that's where it's defined. We can have a quick look, one moment, so that you can see at least how to find it. So let's look into Nix packages. So that's the Nix packages checkout if you just check out the repository. In NixOS/module/virtualization.qemu vm.nix. That is what your VMs contain. Looking for the option virtualization.writable store. That's what you would set to true. And then we get a Nix store that's kind of read-writable. I don't know for sure. Oh yeah, and here you can actually set if this is a tempfs. So that's just follow-up question, right? Tempfs means that will be in the RAM and everything will be lost. And if you set that to false, I'm not sure what happens exactly, but we could kind of study that in the rest of the code now. If writable source is dead, then okay. I would need a moment to understand what this really does now, right now, but I hope it answered your question sufficiently. Okay, very good. Right, so we had to look at the non-interactive driver, which runs in the sandbox, and at the interactive driver, which runs outside, and how we can connect into the VMs, because to have the window in front of us is very nice, but not always the coolest thing. There's another test that I want to show you that tests like graphical stuff. So we can say nix build.hashtag browser. It opens the browser and tests if it can access everything. I would not run it in the sandbox now because that's very boring. So let's immediately start with the interactive test. And then we run this. Say run tests. We'll go through the implementation soon. I just want to show you first what it really does. So running a server and a client. The client is the graphical machine. Now we see a desktop popping up there, like a very minimal, I think it's LXDE or something, it's just small. And there we are starting Firefox. And what's interesting about when you start Firefox for the first time, there comes this welcome to Firefox thingy. And then we close it again, and we are actually using text recognition now to find out if there's the quit Firefox button. Then we quit Firefox, and when we launch it for a second time, it will actually launch on the website that we want it to. And that is the server address, where we just configured an Apache web server. That Apache web server would show this it works page if you use the default config. And we want to test if that works with text recognition. So that's the toy scenario that came up with. And I want to show you how to code something like that. Typically, the test would succeed here. And of course, we don't need to quit Firefox if everything will collapse automatically anyway. So it just stays open. But here we can just, play around with everything, right? Because it's a real desktop. And that's pretty nice. Server is also still running. Let's quit that. And then here you can just continue playing if you like. In GitHub Actions, we typically get KVM support. And if you use the determinate systems installer actions, actually tests for KVM support. And then you get that with nice performance, actually. I don't know which specific problems you had, but maybe you can experiment with which version of Nix installer action you use, because I know that it generally works. If you like, we can sit together after the session if you had some more specific problem to look into it. Okay. Let's exit now and have a look at the implementation. So in the browser test, we are saying, okay, we're generally enabling OCR. So that adds more dependencies into the test driver that you typically don't need if you don't have OCR. In the default settings, that's getting thrown into both VMs then, right? We're disabling the firewall. We're also setting the display resolution to 800 × 600, otherwise it would blow up the small screen here. And then we're configuring the two machines. So the server just has Apache running, relatively boring. And the client, here I'm reusing the X11 module from the NixOS tests folder because there are multiple tests that use a small and slick desktop, and I'm just reusing the profile from there. Then we're installing Firefox and also the so-called xdo tool, which allows us to shell script certain actions on the desktop with the mouse. That's already it. I'm using this little trick here in the top that I use from the test module system, the packages attribute, to extract the Nix packages path, and then actually peek into the NixOS tests common X11 folder because that's in the test folder. And then let's ignore the interactive part here. The test script accesses the nodes client configuration to select the right Firefox package. And then we're running Firefox back there. And here what the test does is, it again does this network waiting dance. Then we succeed pinging each other because we don't need to test Apache if the network doesn't work. And then there's some helper functions for X, which are all documented, so just skip over them now. And we are running Firefox on the About Welcome page. I did that as a first step because I know that if you run Firefox for the first time, it will very often ignore what site you're opening now because it wants to show you, hello, welcome to Firefox. So we're kind of opening this. Then we're waiting for the window Firefox to appear. Wait for window will just enumerate all the window titles that you have right now. So you don't need OCR for that. And then I'm pressing Control Q. So I'm sending the command to the desktop here. And here I'm waiting for the text. Wait for text means it will frequently make a screenshot, run OCR, and print all the strings that it finds. And then you check if quit Firefox is part of that. And if it isn't, it would wait a few seconds and make another screenshot, and it will just loop here. And here I was annoyed that sometimes some version of Firefox uses a capital Q, some other version uses a capital F, and you can already see that this is kind of regular expressions, right, which make the test more robust. I stumbled upon that, so I think like last year or something, I gave this demo, and before that I updated the inputs, and then the test didn't work. It was really annoying, and I felt like, oh no, that's another demo's live coding scenario where stuff doesn't work, right? And they switched the capital F and Q thingy. That doesn't happen to me any longer. Then we're sending a space because the quit button is highlighted, and if that ever changes, then this test is broken again, of course, right? That's how it goes. Yeah, and then we start Firefox, and we get the screen text. And here we can see that we basically get a string with all the string content here. And then I want to see it works there. And what we can do now is we can also like print screen content, print screen content, and rerun the test and see what else it discovers. Let's run it and see. The whole test is a bit slower because I added some wait steps here and there. You can see that, you have seen that I added sleep 5 seconds steps in between. That is not the greatest way to do this. You should generally have like synchronous waiting on certain events because that test will on a very slow laptop maybe exceed those 5 seconds and then it's broken again, which actually happened on one of my older laptops. But however, let's not make too much of a science of it in this scenario. Yes, please. Can I have a timeout on the individual weights? Yeah, so all the succeed and fail and whatever methods, they very often have an additional optional parameter. So you can have like a generally very huge timeout and then very small one on certain commands. Yeah. Here, you can see the output now. There's at least it works. But also found other things like open previous tabs, question mark, you can restore this and that, blah, 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 not secure. So you can see that it found all kinds of strings. This is, of course, very unstructured, but it's just OCR running, right? So it's kind of neat, but not perfect in many regards. And very often I wouldn't use OCR because also relatively CPU intensive. It runs Tesseract. And And if you can query your applications for more structured output, you of course should. But right now I just want to brag with the OCR, so we just did it with that, right? Okay.
Why did you have a client.network screenshot in the test?
Do I? Oh yeah, to show that we are actually getting this screenshot in the output folder. Okay, so this might be cool if you want to have like documentation with screenshots that are up to date. Then you can actually have your tests or something generate them. So this might be a use case. There was once a patch that actually could film the output. So someone was testing his games and wanted to film this stuff, but that stuff never made it upstream because there was a lot of discussion. Okay, now the next thing I wanted to show you is containers. When we go to the ping test, we can kind of change this to containers instead of nodes, and it would just work. However, in the PlanetNix file, I'm using normal upstream Nix packages. We need to fix that because it's not yet upstream. It could happen any day because the pull request, there's a lot of discussion going on, but we're converging already. If you want to test this now, you would just use the applicative systems Nix packages fork. We generally don't fork Nix packages, it just contains this branch, right? That's the branch that's in the pull request. NixOS test containers. If I now rerun this, we will kind of download Nix packages again, but have the different version of the driver now, which does support containers. Now we can say nix build -l ping. And we're running. The output is practically the same because the containers that we use, it's not Docker or something, it's systemd-nspawn containers, which means that you're running a systemd tree inside your systemd tree, which is something that systemd supports. It's relatively complicated because you have a whole set of like user ID and group ID ranges that need to be mapped between the container and the host and stuff like that, which something that the systemd community is working on to streamline this more. There's also limitations that you can't have the super user ID bit being used and stuff like that, but it works pretty flawlessly with many scenarios. And you can see already that the whole test ran in 3.24 seconds. I don't know what I did because yesterday it was 2.4 seconds. However, maybe my laptop is running in some kind of power save mode or something. Balanced. Oh, let's see if it runs faster if we change something here. However, everything below 5 seconds is pretty nice. Let's run it again. I just changed something again to invalidate the cache and have it run again. And switching from nodes to containers in the top level attribute set was everything that we needed. It's 2.7. Okay, some noisy laptop, however. When we change back to nodes, we can measure again how fast it was, right? Oh yeah, here. Nodes. So 2.7 seconds against. You already feel it's much slower, right? It was 6.8 seconds. Still relatively fast to just spin up two VMs, ping each other and so on, but it's twice as slow as the container tests. In general, you don't have this overhead of a booting kernel, right? Because we just reuse the host kernel, which also means you cannot change the kernel. So that's the trade-off. But the most amazing thing about this is to run this test with containers, you don't need bare metal Linux running with KVM support, right? So you can use cheap VMs from Hetzner for $3 per month, whatever, and they would just run fine your container tests without any overhead, which is amazing. If you ever run into scenarios where you need like 100 hosts, The containers can do that. A container is cheap and light. You can have 100 containers running on a cheap laptop at the same time. It would be more difficult with VMs, of course, because they consume so much RAM. So this is a huge liberation from specific bare metal requirements on your build infrastructure, because you can just spin up cheap VMs that run all your tests just fine if you can use containers in that case, which is, of course, not the case for desktop tests or whatever, right? Okay, so there's not much more to change. You can just, it's just that the nodes versus containers thingy means that we are not importing the QEMU vm.nix profile, which comes with all kinds of virtualization.memory size, virtualization.display resolution, and so on, config parameters that are not available with containers. And then containers have other attributes that you can read up in those profiles back there, and that's basically it. So if you're using some virtualization.whatever setting, then that most probably means that your test won't run with containers, which is totally fine. There's one other thing that you need to set up before those container things really work. I can show you my config here. Oh no, modules. So here, that's part of my laptop config. Which version of Nix I'm using is not really interesting at this point. It's just that we set auto-allocate UIDs to true, enable those features here, and whatever else. So that's kind of the part that we need here, because we're using features now that are not default. This will also be merged with the new documentation so that you won't have to dig this up yourself. What's also interesting is that for the special case of mixing containers with VMs so that they see each other in the network, we need this specific extra setting down here, because the thing is that the VMs are running with specific network settings inside the network namespace of the sandbox, and the containers are set up slightly differently, and they need to be connected together. And for that, the test driver needs access to the /dev/net device, which is necessary to spin up new namespaces and so on. So without that, you will see that VMs and containers can ping each other. If you don't need that, then you don't need to care. If you have VM-only tests or container-only tests, it's not necessary. But if you want to mix it both, then this is another extra setting that you need. We will also carefully document that. It's also the case that the test driver warns about this, but it might be possible that you don't see the warning if you try it out. So I wanted to mention that.
Is that the same way that you're doing device pass-through?
Yeah, kind of. So if you want to test like an NVIDIA card GPU inside the sandbox, then you would need to make it available to the sandbox first, and from the sandbox you map it into the container. And the host configuration controls with this setting which paths are available and which are not. Yeah, so NVIDIA machines come with a whole list of paths. That was, one moment, at the demo somewhere here. All these paths need to be available in the Nix host setting in order to be forwarded then as a second step into the container, right? As soon as that is merged, I will publish a blog post about this, because we're pretty proud that this works. It's relatively boring to set up. You just need to not forget anything. Sorry again? So in general, if you wanted to test Docker-style containers, which are single-process containers, essentially, right? With Docker via Podman, you can run these inside NixOS VMs all the time. We also have tests for that. Now, if you actually want to substitute the VMs or containers against like Podman or Docker thingy, that's the thing is Podman needs the superuser ID bit to be serverless. Docker uses a server, and you would have to set that up inside the Nix sandbox without NixOS. And that's kind of, that wouldn't lead you anywhere after having a lot of work. And then you would just be able to run a single process. So that's people typically test Docker and Podman and Kubernetes and whatnot scenarios just in those VMs. Okay. Yes.
Well, now,
Mm-hmm.
can you use containers?
No. This is 100% Linux namespace specific. Systemd is also very Linux specific, right?
You could have like a proxy VM and then run a container inside a VM.
Yeah, so the easiest way to leverage this, to not have the overhead of like 15 VMs instead of just use 15 containers, would be that you define a test like you would run it on Linux, and then you build the Linux target, which would make your Nix daemon on macOS delegated to the Linux builder, which runs in the background, and then it would run just fine. So you would just say nix build and then #, packages arm64-linux.mytest, and that's already it.
And the second one is would it be possible to run the post
The VM test using Apple hypervisor within QEMU?
So the question is, when you run this on macOS with VMs, if you can run the Apple hypervisor instead of QEMU. Yes, that would be possible, but someone would have to package a hypervisor that actually runs on top of the Apple virtualization framework, and I think no one did that so far. It might come with the advantage of being much faster and so on, also being able to use Rosetta and so on, but no one did that before. We are, however, totally open towards consulting gigs that do that if someone requests that. Like with the container edition, right? Yeah, okay. The host config was my last planned part of this. If you have any more questions, please shoot. Yes, please. Yeah, so we can, of course, just as we did before, just build the driver. Let me check if I still have it on nodes or it's containers. Yeah, nix build that. At this point, I was sometimes building .driver, sometimes .driver interactive. It doesn't really matter at this point. We now run results bin. You can see this script is the nspawn start script, right? Oh, let's copy this only. That is the command line. Let's split it up. So we run nspawn. I'm not sure what command that is right now. Some time ago when we wrote this. However, we kind of give it all kinds of configuration here and the init script and so on. And then let's have a look into this actual application here. There's another wrapper, of course. Here we're setting up all the systemd dependencies and whatnot. And there's, of course, a Python script. Oh, yeah, right. I remember when we go to NixOS modules, virtualization, and systemd-nspawn, nspawn container, you see the configuration and the Python script that we just were about to have a look into is here. So this is a wrapper that basically accepts the configuration from the test driver and then runs the command here. It sets up all the namespaces stuff and whatever log files and blah, blah, blah. And at some point, we're finally running systemd-nspawn. Okay. Here's the systemd-nspawn command. With the options that were dynamically kind of set together depending on the config and the state directory and so on and so on. So this is actually pretty hackable. You can look into it and yeah, it's relatively new. I hope that answered the question sufficiently. Anything else? Yes, please.
Isn't it a spam bunch of hosts? Because this way, we were running and then map port that one to the host and then run tests like run some like cargo integration tests as a thing on the host that you on the host that you on the end.
Yeah, that would totally be possible. So I would rather consider that as a developer scenario. Let's say you have some kind of LAMP stack where you want an Apache running and some PHP scripts that you develop and then a database and everything. And that may be possibly as a multi-host scenario. So you could actually run the test driver as an interactive session and spin up this kind of infrastructure for you and then map folders and map ports around to give you a nice developer environment to spin that up. However, if you are able to describe halfway automatically the actual test, then I wouldn't run it on the host. I would also integrate it into a test because you would want to nail it down in a way that it runs reproducibly in the sandbox anyway, right? So this is...
We trying to bring this, and you might have like a client that you're working on that is for NixOS.
yeah.
You want to start bringing this stuff in and say, hey, look.
Of course, if you had a scenario where you need those VMs to have network access because you are accessing, I don't know, some Okta or whatever service from outside, and you can simply assume that it's always available because it's a huge impurity, right? But that's running it outside the sandbox would enable you to do that. And you can always have like, I don't know, GitHub actions or whatever that run the driver interactively and wire it up with some real life stuff outside. It's just, that would be a huge pain if something on the internet changes and that makes your tests flaky, right? So you will want to avoid that. It might be worthwhile to actually set up your own key cloak inside the sandbox and then do some kind of... I was just writing further on the example. If you have some tests that depend on some kind of Okta authentication service running outside there, to fake that with some open source thing like Keycloak or Authentic or whatever inside the sandbox would be worthwhile because then you are under control, right? But asterisks is all possible, yeah. Anything else? Okay, we're very much on point. So thank you for your interest. All right, I wish you great fun and success with the test driver, as thousands of people out there use it, and it's actually more fun every year with all the improvements that we got. And last year it wasn't as fast as it is right now, and even with the containers, it's unbelievable what kind of complex scenarios you can set up with just a few lines of code and have it actually to be really quick, right? So, have a nice evening.